Whoa, what's happening here? Sorry guys, just checking. All right, quiet so far. That's pretty good. All right, guys. So because we got a quiet night here, if there's any requests, no worries, Pulandu. No worries, Vickers. All good. If there's any level 3s that are here and want to work through some questions, just let me know. Yeah, Pulandu, I'm gonna have a look at the exam paper after the level 3s are finished. Hopefully in the next couple of days, I might just have a look through the papers and just kind of think about how to answer them. No worries, Zach. That's all good. Reject, I've been kicking this channel for nearly 6 years, man, so no worries. I don't know who's actually jumped in yet. I kind of have lost that piece of paper where I was supposed to do some questions, but I have tracked, I've got questions that I have done. Still hilarious here. So hit me with some questions, guys. Whichever one you want, like NCEA, well, the calculus, calculus papers. As you can see, I've been doing 4 hours of streaming in the last 24 hours. I'm a bit nutty at the moment. Vikash, no worries, man. You're welcome. I'll catch you up next year for level 3s, so all good. Edran, Rory, welcome, guys. What do we want to work on? Oh, geez, suddenly we've got a boost in numbers. Actually, look, what I might just do is like I might just give you guys a couple of yeah, look, it's you know, it's kind of like the last minute thing here, but what I might just start this session with is just some strategies on how to actually get the best grades for tomorrow. All right, Robert, what was that one? Was that differentiation 2017 1E? Okay, so my kind of thinking behind approaching these papers for tomorrow is this. Just understand this, all right? Depending on whatever your grade you're getting, it really doesn't matter what grade you're trying to get. Best thing is that you've got to have a strategy that you go into for level 3 papers. So remember, each time you're going to have like question 1, question 2, and question 3. What generally happens is that you got one AB, CD, and an E. So that right there, you know, you get M5 for M6 for getting 2 merit questions right. The final question, E7, is with a minor error, and E8 is like full grades. So if you guys plan this, right? What you ideally want to be looking at is 20 minutes for each question. Time yourself like this, 20 minutes. Now, if you're the type of person that a bit nervous about tomorrow's exam papers and you're like, I just want to get an achieved, that's all I care about, then I would actually say, regardless of whatever, you should really start with question 1C and D, because they generally tend to be the merit questions. They give like the achieved questions at the right at the start. And I hope they keep that formatting, because if they don't keep that formatting, then it becomes a bit tricky. But assuming that they keep that formatting, I would actually say attempt C and D, because that gives you maximum points for like limited amount of time. For those of you that are aiming for excellence, once you read through the questions, you kind of can understand which question is going to be the excellence one. And ideally, you should only spend about 10 minutes on the excellence question, on the final question. Because the reason I say 10 minutes is because after 10 minutes, if you're not going anywhere, then go back and make sure you definitely get C and D, so that you actually get M6, which is like the maximum points you can actually get. TIFE, I'm actually going to be doing a review of that later on, man. Like, just give me a few days just to settle from all these other exams. All right, because for potentially for an excellence, you could actually get an M6, M6, and an E8, which sums up to 20 points. On the odd occasion, they'll turn the paper into 21, but just remember that, all right? So you really need to target one excellence question to be getting it at full 8 points. And yeah, so I would actually say that M6s are as important as going for those E questions. All right, and remember, if you do an E question, and if you're kind of stuck halfway, you could still get achieved a merit for that anyway. So strategy is this: go in, read the full paper at the beginning. All right, do not actually start question 1 straight away. Just make sure you yes, Leah, you can, because most of the E8s work like this, where it's in calculus at level 3 is that if you get the full excellence question correct, you get an E8 for it, because most of the time they only have one excellence question per what do you call it, per question. Like out of the 3 questions, they only have like one of them. Let me just double check that, because I'm sure of it. So I'm just gonna do, which question was it? Yeah, so E7, like I'll screenshot you guys what the schedule looked like from last year. Not great. I'm having some syncing problems, so which means I can't actually show it to you yet. Give me 1 second, folks. Just trying to sync. Because that's really super annoying when it happens on this time. Yeah, basically what I can see is that for E7 you get 1T with minor errors, and then if your answer is fully correct, then you can actually get E8. So this is what they generally have for the questions. So what I was talking about, like, you know, if you get like that C question there, that's your D, and then that's your E, and 1A, 1B is there. Okay, I think like attempting the merit question is just so much more easier for those guys that are trying to just get through the paper. Because even if you do half of the merit question, you can actually get an achieved grade for it, and so on. Minor error is if you have a look at not like rounding or anything like that, but sometimes you make like carry-on errors right at the beginning. Nah, not units, Robert, not as bad. Like, you know how, do you remember earlier this afternoon when I did that equation, I think Leah, you were there for that one, because we actually had that this question here. Where was it? It's the complex number question which I made a mistake in. This one that we did. No, not this one. Where the 7b question. Yeah, this one. So remember how I actually wrote this as +7 instead of 7y? So that was like a mistake. That was a minor error. And I think because I made that mistake, it would have ended up being a E7 and not an E8. Because most of my working was actually there. Okay, so in saying that, I think we did have one request for a differentiation question, but I thought I'll do one question from each just to kind of recap again. Robert kept asking me this question, 578. Oh, this is actually a good question. Okay, so I'm going to do this question here, folks. So just bear with me. Just got to cut and paste. So this one is from 2017. Differentiation. Nick, I've got an entire tutorial set up on that on my differentiation playlist, so have a look, man. How many points to pass a paper? Each paper is different. Like differentiation, yeah, the cut scores change, guys, depending on the year. So I really can't actually answer that one. Yeah, Jessica, there is a video on my differentiation tutorials playlist, so have a look at it for the limits question. And I think I did a rates of change tutorial as well, so have a look at that as well. Anyway, let's get through going with this question here. So what we've got here is we got to find values of a and b so that this curve actually has a turning point at 3, 1. So, I mean, again, guys, like, I know this looks like an excellence question. I mean, it is an excellence question, but for differentiation, always remember, even if it's an excellence question, have a look at the formula, and if you differentiate it, you can actually get an achieved for it. Yeah, that's absolutely right there, Modularis. So I would say that reject. Let me just no, I can't. No, I'll have to leave it as it is, man. I don't want to waste time today. So, okay, so we're going to differentiate this, all right? So we've got y. So I'm just going to rewrite it as f of x, just because it just makes it easy for me. Ax minus b over x squared minus 1. So when I do f dash of x, what I've got to use is I've got to use quotient rule, because we've got a fraction here. So when I differentiate ax minus b, I'm going to get a multiplied by x squared minus 1 minus ax minus b, and then differentiation of the denominator, which happens to be 2x. And all of this is divided by x squared minus 1 to the power of squared. So just doing this here gets you a achieved straight away. All right, so and I think that's something that you guys actually need to remember. If you in differentiation, you just differentiate and you should be pretty good to go. Now it says that it has a turning point at 3, 1. If it has a turning point at 3, 1, that means f dash of 3 equals to 0. So because f dash of 3 is equal to 0, I can put this as 0 equals a times x squared minus 1 minus ax minus b times 2x, and all of that is equal to x squared minus 1 squared. Now cross multiplying this, 0 multiplied by the denominator is going to be 0. So I'm going to get 0 is a times x squared minus 1 minus ax minus b times 2x. So expanding the brackets, I'm going to get ax squared minus a, and then here I've got negative 2ax squared. Negative times negative b is positive b, so plus 2xb. Okay, this is where I got up to. Now, I think the one thing that I forgot is that we can actually substitute x is equal to 3, because remember f dash of 3 is equal to 0. So what I'm going to do is I'm going to take this 3 and just chuck it in wherever x is. So we're going to get a 3 squared minus a minus 2a times 3 squared plus 2 times 3 times b. So when we do this, we get 9a minus a, and I've got 9 times negative 2, which is negative 18a, plus 6b. So which gives me 0 is equal to negative 10a plus 6b. So that's good, because I can actually say 10a is equal to 6b right now. All right. Now that's the first part of the question, and I think for this one of the two equations relating a and b, I think in this case you could potentially get a merit at this point. All right. Now one other thing is, if we go back to the question actually says that right here it says that it has a turning point at 3, 1, which means we also know that f of 3 is equal to 1. So we can actually do that now. But we can actually say, not f dash, sorry, f of 3. How come the a is multiplied by x squared minus 1? Nicholas, what I'm doing there is quotient rule there. So if you have uv, remember that differentiation with quotient rule is going to be u dash v minus uv dash divided by v squared. Okay, so going back to this part here, so we can actually say 1 is then equal to ax minus b over x squared minus 1. And what we're going to do is we're going to substitute 3 to wherever x is, and we're going to end up with 1 is equal to a times 3 minus b divided by 3 squared minus 1. So 1 is equal to 3a minus b over 8. Cross multiply, we get 8 is equal to 3a minus b. So what we've got here is a set of simultaneous equations, and we're good to go, because what we can do is, I'm just trying to do it real quickly here. So we can say that b equals to 3a. Oh, you know what? I'm not even going to bother that. I'm just going to put this directly in the graphics calculator, because I've got this other equation, 0 equals minus 10a plus 6b. So I'm going to use simultaneous equations, guys. I'm not going to waste time. So go into equations, simultaneous, two unknowns, chuck in those values. So you got 3, negative 1, and 8. And then you've got negative 10, 6, and 0. There's my two values. So a is equal to 6 and b is equal to 10. Robert, it's usually the other way around, because for integration you actually need to know how to differentiate. Yep, so that right there, guys, gets you an excellence question. Yeah, Dave, B, I usually say that to people as well, like it's just a waste of time because you're just sitting there plugging it in the calculator and doing things wrong. Kevin Fu, it's absolutely fine to use simultaneous equations in graphics calculator. There's nothing that says that you need to actually show it. Just like how you get a quadratic in your graphics calculator, you can just solve it straight away. All right. Who you say it's harder to merit differentiation or integration? I don't think I understand that question fully, Cameron. Abdul, which last part are you talking about? Are you talking about the part in the red box? The red box is just simultaneous equations, Abdul, just from level 1 kind of things. To Cameron, merit in either paper. It's personal preference, man. I think whatever you guys do. Shanok, I'll probably say if he's just trying to pass one standard differentiation, because I think differentiation, if you just differentiate every question in each paper, you can actually pass this entire paper correctly. Mitesh, 2016, question 1E. Let me have a quick look, eh? By the way, guys, if anybody's looking at some basic integration, I just thought I forgot to mention this. I'm just going to tag in another maths teacher who's actually running a cram session at the moment on Twitch. So go check him out as well. He is doing just achieve questions on integration at the moment, just having a real quick look at what he's doing at the moment. Okay, so where are we up to? Can you explain a cone? Sachin, I did a question like that before in my previous tutorials, man. Mitesh, I think I will be doing a differentiation question, but I'd prefer doing a complex number question. So if anybody has a quick complex number excellence question, just throw it out, because I want to do one of each. Nice. Indie Bear, was that complex numbers? Sachin, the best way to do it is, let me just, sorry, I forgot to actually link that here. Just give me a second. One second. I'm trying to find my link for my OneNote so you guys can actually just where is it? Sorry guys, just give me 1 second. Just want to find it. Notebook, here we go. So if anybody wants to have a look at my notebook, edit video. All right, Sachin, if you refresh my description, like this video right now, what you should see is a link to this notebook, and in there you'll see all my previous questions that I've done, which are the so this is like, there's a playlist for each of, in the playlist you'll actually find the titles put up like this. And then if you want to do complex numbers, I've actually got questions for that tutorial on complex numbers. Differentiation tutorials are there, integration is there, and so on. Okay, so I would say that's probably the best way to go back and have a look at it. 2018 paper I've already done, guys. 2015 Indie Bear, you said complex 2016 2e. Okay, did I not do that before? Okay, 2016 2e complex number, that's the one we're doing next. Oh wow, okay. This is actually a really good question to kind of keep in the background. Okay, just give me 1 second. I'm just going to paste it and then get it started with question 2016 2e, complex number question. All right, patience, guys. I'm going to go through this question first. So what we've got is we've got to try and figure out what the value of k is so that it actually has equal roots. Now, and it's really weird because, I mean, like, you might have done this in level 2. You don't really talk too much about equal roots in level 3, but it's just something that you're expected to remember. So remember, if it says equal roots, that means b squared minus 4ac is equal to 0, because that's the discriminant for one root, or saying equal roots. So the first step we've got to actually do is we've got to rearrange this. We've got to rearrange this so that we can actually get rid of that square root. So, and I think this is a useful skill to have, because I've seen people mess up so much in this. It is sad. So what we're going to do is we're going to leave 2x plus k on this side, but we're going to move x and 8 to the other side, which makes it x minus 8. And once we do that, now what we can do is we can actually square both sides. When we square both sides, now 2 squared is equal to 4, and then 2x plus k, the square root just gets removed. And then this becomes x squared minus 16x plus 64. Dave B, perfect square means that discriminant is equal to 0, that's all. They just tricked that word. Yeah, Nathan, it is the same as repeated solution. So all those level 2 kids that were talking about perfect square, all they had to do was just put b squared minus 4ac equals to 0, because perfect square means you only get one solution. So what we're going to do is we're going to rearrange this and put this as 0 is equal to x squared minus 16x plus 64 minus 4 times 2x plus k. Expand the brackets. We got x squared minus 16x plus 64 minus 8x minus 4k. Yeah, I know, Leah, that's why I was actually kind of doing this question, because I know sometimes people do that. So we rearrange this, we're going to get x squared minus 24x plus 64 minus 4k. Now this is actually a surprisingly easy excellence question at algebra. So just getting up to here gets you a grade of merit. And then to get that excellence part, remember that b squared minus 4ac equals to 0. So our b value is going to be negative 24. Our a value is going to be 1. And our c value is going to be this entire thing, which is 64 minus... Yeah, it is, Dave. I'm not going to lie. So then all you got to do is negative 24 squared minus 4 times 1 times 64 minus 4k equals to 0. So k is equal to 12. You already done that. Awesome. And again, right now I'm super lazy. I can't be bothered doing all of this. I'm just going to go into Solver and just chuck this in. So I've got negative 24 squared minus 4 times 1 times 64 minus 4, and just use alpha k, put it equal to 0, shift equals to 0, enter, and solve. I'm getting k equals negative 20. And I check the answer, k is equal to negative 20. No. The perfect square question was, it's the same thing as this question, Leah. It is just, it just means that discriminant is equal to 0, that's all. Okay, next one is integration, guys. Yeah, you're absolutely right, Dave. If possible, would you be able to look at this question? Bronson Skipper, I've done an entire 1-hour tutorial on those ones. All you got to do is just substitute 2 minus I in that equation wherever z is, put it in the graphics calculator, and then you're good to go, man. Somebody asked me for 2015 question 2e complex number. I've already done it in the afternoon's tutorial, guys. It would be nice if an excellence question like this comes for you guys for algebra. I'm not gonna lie, you know, for a change. 2 more harder questions. Okay, I'll put up another complex number question here. And again, this is sometimes people just leave these questions empty, which is quite frustrating. But I'm going to show you guys how easy this next question is. This is just from the same exam paper, 2016 1E from complex. Abdul, because it was in the previous question, it was equal roots. So if you have a look at it, right there, it said equal roots. And because it's equal roots, that means you only got one solution. Subscribe to, yeah, okay, whatever that whole thing is. The complex numbers paper is up. Just have a look at the complex numbers exam paper. I've actually done a full exam paper for this. Okay, so this complex number question here, and this is something I was talking to you guys about earlier, is this. Whenever you see a question like this, right, even if you don't know how to start this question, just write z is equal to x plus iy and just substitute the hell out of it. Yeah, you're absolutely right there, Brianna. So if you want to try and do that, so what I'm going to do is put z is equal to x plus iy. Then remember that this little symbol here is the modulus. That means you got to go square root of real squared plus imaginary squared. So always remember that part. I haven't seen it, Osteo, because I haven't actually taught it. But it's always a good question to kind of keep in the background. Anyway, so I'm going to get rid of z and I'm going to write it as x plus iy minus 2 plus 3i is equal to x plus iy minus 1. So I'm going to replace this now with, and you can actually do this if you want, the real part squared plus imaginary squared, and then here real part squared plus imaginary squared. So for the real part, I've got x minus 2, so I'm going to write that down, x minus 2 squared, plus imaginary part is actually y plus 3, so that's going to be y plus 3 squared, equals, in this case, the real part is equal to x minus 1, and then the imaginary part is simply just y by itself, so plus y squared. Yes, Leah, you can also do that for argument type questions as well. So guys, and if you've got two square root symbols right next to each other, you just get rid of it, and what you end up with is x minus 2 squared plus y plus 3 squared is equal to x minus 1 squared plus y squared. Now all you got to do is expand. Yep, Nicholas, you can. Because it is one square root is equal to another square root, you just get rid of the square root completely. Ignore it. Robert, which year is that? Okay, so now we just expand the brackets. So we've got x squared minus 4x plus 4 plus y squared plus 6y plus 9, and then x squared minus 2x plus 1 plus y squared. Then go on a cancelling binge, so get rid of y squared, get rid of x squared. What else could I get rid of? Oh, a bit anticlimactic. That's it. So we've got negative 4x plus 6y plus 13 equals negative 2x plus 1. So rearranging this, we're going to get 6y is equal to negative 2x plus 1 minus 13 plus 4x. I think I have a feeling I've done something wrong here, but no, that looks right so far. So 6y is equal to 2x minus 12. So y is equal to 2x minus 12 over 6. And we end up with y is equal to 2x over 6 minus 2. Now, if you go back to the question actually says, find the gradient of the line. So the gradient of the line is this value here. So we're going to say, therefore, m is equal to 1 over 3. Super easy excellence question for this one. Yeah, everyone keeps going back to 2017 1E. Yes, Ellie, we ignore the I. So remember, whenever you see a modulus question like this, just replace it with z and just start working. I'll show you guys where you actually get a merit from, because this question you get merit at the fourth line. So 1, 2, 3, 4. Here we go. Just to show you guys what this paper was like, this line here gets you a merit just up to here. That's worth 5 points there. Okay, integration 2017, I've done 2017 1E integration. Integration 1E. What's the damage for this one? Oh, this one. Yeah. Yep. Yeah, I've seen these types of questions every now and then for integration that pop up. These stupid substitution questions. So this is integration 2017 1E. Oh, is Hash doing what's he doing? Yeah, he's actually doing achieved questions at the moment for integration. Okay, so this question, people ask me how to actually do this, right? One of the things is sometimes is just kind of reading through it. Give me a second. So mean value function of this, blah blah blah, b divided by a, b minus a. Find the mean value of y equals sine 0 pi. Yep. Okay. Cool. So x is equal to a pi, blah blah blah. Okay. So if we're going to write this equation, all we've got here is this. We want to find, according to this equation, right? If we take the mean value equation, the mean value equation is between b and a, f of x dx over b minus a. So let me start highlighting a few things. The b value is that pi there. The a value is that 0 there. I should have used a different color. Apologies about that. Give me a second. So a is going to be this 0 here. The f of x, that's sine squared x. So when we really think about this question, it's all we have is it's between pi and 0, sine squared x dx divided by pi minus 0. That's all what the question is actually saying. Yeah, so now remember that you can't actually integrate sine squared x. So you've got to actually go back to the formula sheet and rearrange it. And I think, did I close that stupid sheet? Yes, no I didn't. There we go. Give me a second guys, just pulling out the formula sheet. And I want to write sine squared x in terms of cos. So I am going to be using a double angle. Okay, so because I want to get rid of sine squared x, when I go down here, I can see that this is the one that I want to be using. So I'm going to rewrite this as cos 2x equals 1 minus 2 sine squared x. And this is really important, guys, this part, because sometimes people actually forget it and they start integrating sine x and start doing some really silly things. Okay, so we're going to rewrite this as, rearranging this, we're going to get 2 sine squared x equals 1 minus cos 2x, and then sine squared x equals 1 minus cos 2x over 2 and over 2. And because we got that, what we're going to do is we're going to replace sine squared x with this thing here. And so what we've got here is between pi and 0, and instead of sine squared x, we've got half minus cos 2x over 2 dx over pi minus 0 is just pi. So integrating the numerator, I'm going to get x over 2 minus sine 2x over 2 multiplied by 1 over the differentiation of whatever's inside the bracket here, which is going to be another 2. And of course, this is between pi and 0 divided by pi. So substituting pi and 0, well, I've got pi over 2 minus sine of 2 pi over 2 times a half minus 0 over 2 minus sine 2 times 0 over 2 times a half, and the whole thing is divided by pi. So all we've got here is pi over 2. Now sine of 2 pi is 0, so this entire thing is going to become 0. Don't have to worry about it. 0 over 2 is 0 minus sine times sine of 0 is also 0, so that's going to be 0. Whole thing over pi. Basically end up with pi over 2 divided by pi, which is equal to just half. And that's your excellence grade for that. And for merit, you could get a merit here. I thought I'd actually done the 2017 differentiation questions, but let me just double check. So Abdul, when I went from, just going to put some lines here just to make it. So when I went from line 1 to line 2, I haven't actually differentiated. All I've done is I've just rewritten sine squared x as another thing. Now, who was it that questioned? Prakash. Prakash, was it that you asked? No, not Prakash. What was it? Mitesh. From the integrated function, do you need to do the rest of the subtracting, or can you put it in the calculator from the beginning and show integrated equation between pi and 0? Mitesh, you can absolutely do that. So I would actually say from this point, you can go right to here. Because as long as you know how to integrate, but just for safety's sake, what I tell people is like do line 4 and then go straight to the final answer. All right. Couldn't you integrate it without converting it to cos? No, you can't, Abdul. Because it's sine squared, you can't actually convert it. Buckley. Buckley is a legend, man. Do say hi to him from me. All right, we've got 2016 1D. (2015) 2E differentiation. Sorry, Dave, was that integration or differentiation, man? Uh, 2015 2E. Okay, let me just have a look, man. $578, 2015. Oh, I know which question you're doing. I actually did this question before, man, in one of my tutorials last. It's in one of the help desks that I did this, so I'm not gonna do that one, Dave. Code, check out my complex numbers live tutorials. I think the first 2 tutorials are basically to help you get 10 points easily with a couple of the few merit questions that they actually ask. 2014 integration 1E or 2E. No worries, Ferrari. But if you do see him tomorrow, just tell him I said hello. Edrin, you can't actually you can't integrate sine squared x. Okay. Tushar, I'm not gonna stick with that question, man, because it's if you guys tell me where that question is from, then I can pick it up. Because I know it was not just you, that's been Casey's been going on as well. Yeah, Brianna, you're right, but you can't integrate it. 2009 differentiation. Jeez, I don't even know what the numbers are for that. Find all the current defined parametrically. That has a tangent that is vertical. No. Sines. I'm trying to see what you've actually done there, Brianna. It's a bit interesting. No worries, Stella. You're welcome. All right, guys. Last question for the night before I head off, because it is coming to the end. Chuck me one more question that I can actually do. I'm gonna skip that parametric question because I need to see the full question first, and some of the old papers I can't really find it. One more integration. Okay, Manav, let me have a look. Manav, what I would do is, I know you started out very well, just expand the brackets for that question that you just sent me. Expand the brackets, match the real parts to 5 and match the imaginary parts to -36, and you're pretty much good to go. 2017 3E. Yeah, osteoporosis. I was supposed to do that 6 years ago. I still haven't done it. Yusha Mia, 1998 calc exam. That's when I was actually doing that exam. Hang on. So many ideas. Which one is gonna go? All right, guys, one last question. I'm just gonna look up a different integration question. 2017 integration question. That we haven't done so far. Actually, we haven't done a kinematics question at all for integration. 2017 complex 3E. Okay, I'll have a look at that one as well. And then 91577 2017 question 3E. Oh, geez, that is going to be nasty, that question. Question 3E. Okay. Time-wise, what have we got? Okay, I'm going to do 2 questions and then I shall be off. No worries, Alizo. You're welcome. We're going to do integration, guys. Kinematics. Robert, did you actually do this in 2017 in my live stream tutorial? Because I remember someone doing the same thing with the whole F thing. Just friggin' annoyed me the hell. All right, so what we've got is integration 2017 question 3E, I believe, or 2E. No, 2E. This is no, Herman, I will not be able to. Actually, this question I actually want to do, guys, because I know that this question has kind of popped up before, and people always get stumped with this integration because it is one of those weird integration where you got to do substitution. No worries. So actually, no, I will do this question, and I'm actually calling it a night as well because I need some sleep. So what we've got is we've got acceleration of this some model by the function of this for this object. We want to know the object was moving with a velocity of 12 when t equals to 4. So we can say that v of 4 is equal to 12. And what we're trying to figure out is the velocity of the object after 10 seconds. So we are trying to figure out what v of 10 is. Harshil, it's actually not too hard. You just need to understand how to integrate it, and then you're pretty much good to go. All right. The integration part is the most challenging part, but after that, it's pretty sweet. So we've got velocity function is integration of 20 ln of t over t dt. Now, here's the thing. When you guys see ln of t and t, just know that this is not a straightforward integration. You've actually got to do substitution, right? So I actually say this, put down u is equal to ln of t, which means du dt is going to be 1 over t. And what I also do is I rewrite this as du is equal to 1 over t dt. Because if you guys have a look, this ln of t could be replaced with u. And the 1 over t dt is right there, which could be replaced with du. So we can rewrite this velocity function as 20u du. So because we've got that, what we can do is velocity is now integration of that, which is 20u squared over 2 plus c, or velocity is 10u squared plus c. So just want to double check that I'm actually on the right track here. Yeah, we're pretty much good to go. Do we need to know about... What's up, Daniel? Where are you confused? Because this is the hardest part in this question. All right, if you sort this out, this question becomes pretty much easy after that. Oh, I've got to finish off this question. Basically, velocity is equal to, because u is equal to ln of t, this becomes ln of t squared, t to the power of squared plus c. Now, Zilu, unfortunately for this question, substitution is the best way to go about getting the answer. Otherwise, it just becomes a bit crazy to try and integrate it. Okay, so what we know is we know that v of 4 is equal to 12. So I'm going to put down 12 is equal to 10 ln of 4 squared plus c. So we can say 12 is equal to 10 ln of 4. Now nothing happens to du because you're integrating it with du. How did you get rid of the t for the denominator? The way I did it was, because remember, velocity could be written as 20 ln of t multiplied by 1 over t dt. That's how I got rid of that dt. And the ln of t was the green part there. No worries, mate. I'm just finishing off this question and then I'm done. Andromedics, no worries, mate. Cool. So basically, this last part that we have, I've just got to figure out what the c value is, and then you're pretty much good to go, because what happens with the c value is just work it out. So c is equal to 12 minus 10 ln of 4 squared. So just going to work it out. Give me a second. So we're getting negative 7.28. 218 was it? Yeah, 218. So then our velocity function is equal to 10 ln of t squared minus 7.218, and we're trying to find the velocity after 10 seconds. So that we just go 10 ln of 10 squared minus 7.218. Once we solve this, we are good to go. I'm just going to go plus answer. So that answer there is 45.8. So grades wise, excellence for this. Correct integration is merit. So that's up there. You get a merit grade. No worries, Austin. All right, guys. No, we do not have to round the answer. No, we don't need to know binomial expansion. I think you guys should be okay for that. No worries, Brittany Grace. You're welcome. Does no units count as a minor error? I don't think units are such a big deal, but I would always, I guess I should really get into the habit of putting it meters per second. Cool, guys. So tomorrow, good luck for your exams tomorrow. And officially, I have to say bye to a lot of you guys who have actually been kind of following this channel for 3 years and just helping me kind of grow as well. And just want to wish you guys all the best in your exams and your future endeavors. Don't be strangers, because these streams, I'm hoping to run it next year as well. So just pop in and let me know how you guys went with the exams. Infinity Fan. Infinity Fan K. Yes, go check out those tutorials, man. I'll put up some tutorials for you, some merits that just keeps popping up. Thanks for the shout out, MATLAB. Guys, that I do have his. Do I have it here? I had it in my previous stream. Oh no, it's there. Twitch, MATLAB. You can find him as well. So do please pass on the messages. No worries, Hyper. You're welcome. We'll do. That's my last tutorial for the year, so I'm looking forward to the exam. Well, not exam, for the break. But I think I'm. Some of these level 2s want me to go through their paper, so I might maybe think about it later on. That's right, Hyper. Last time you were here. Good stuff, Mitesh. Yeah, just for you. It's not last ever, just for this year, man. Not yet, Nicholas, but I don't think I'll be doing it for a while because I am moving schools. Going across the road from senior college to junior college. Appreciate it, Heather. Yes, I'll definitely be keeping this going because, yeah. Going to Ormiston Junior. No worries, Abdul. Just take your time with answering the questions tomorrow, man. And that. Any last tips for tomorrow? Make sure you attempt every question, man. As I say this every single year. Do not leave anything empty. Oh yeah, thanks, Stellar, for the reminder. Sometimes I forget about it, but I appreciate it, man. Can you use the quotient rule to integrate? No, Daniel, no, quotient rule is just for differentiation. Integration by parts. I can't remember that. As I told you guys, I'm not actually teaching calculus this year, so I can't really answer that question. You can, Macintosh. It is possible. Austin, this is me, man. Find me. Music exam. That's new. Casey, I think I've done a video on U substitution in the playlist. If you have a look at my integration playlist, you will find it there. For level 3 integration playlist. All right, so usual it is. Yeah, hash, I think they kind of made a mess with that question in 2015. They just overcomplicated the volumes question. Casey, up to you exactly. It is, Dave. Integration by parts is actually pretty useful at when you get into uni. All right, people, good luck for tomorrow, and I will leave you guys with that. Unfortunately, I can't say that. How do I say it? Like, if you send me questions, I'm not going to answer anything by tomorrow. I am taking a very long sleep because I've been just going non-stop with the tutorials. So good luck, and